Time feels constant, 1 second feels like 1 second no matter where you are, but Einstein discovered something shocking. Time does not flow at the same rate everywhere. Gravity can bend it, stretch it, and slow it down, and the stronger the gravity, the slower time moves. You don't need a black hole to see this effect. It happens right here on Earth. If you live at sea level, your time runs slightly slower than someone living on top of a mountain. The difference is tiny, but measurable. Even the International Space Station experiences time differently. Astronauts age a little faster than people on Earth, and GPS satellites must constantly correct their clocks, or they drift kilometers off course every single day. Time is already bending around you. Now let's leave Earth and head towards something denser. White dwarfs. These are the hot, compact cores left behind when a sun-like star dies. They're roughly the size of Earth, but with the mass of the sun, the gravity on a white dwarf's surface is 100,000 times stronger than Earth's. Here, time noticeably slows down. If you spent 1 year on a white dwarf and compared clocks with Earth afterward, you'd be behind by a few seconds. That doesn't sound like much, but remember, this is only the mild end of extreme gravity. Things are about to get far more intense. Next step, neutron stars. These are some of the densest objects in the universe. Imagine our sun compressed into a sphere the size of a city. Here, gravity is 100 billion times stronger than Earth's, light bends dramatically, matter behaves strangely, and time moves at a noticeably slower pace. If you could somehow survive 1 year on the surface of a neutron star, you wouldn't match Earth's timeline anymore. Depending on the star's mass, your year might equal 0.5 to 0.8 years on Earth. In other words, while you lived 1 year, months would have passed for someone on Earth. Now for the final stage, black holes. A black hole's gravity doesn't just pull matter inward, it reshapes the very geometry of spacetime. As you approach the event horizon, time slows dramatically. To an outside observer, you appear to freeze. To you, everything feels normal, but the universe outside races ahead. Right above the event horizon, time nearly stops compared to the outside universe. 1 second for you could equal minutes, hours, or days, and extremely close to the horizon, years or even centuries could pass in the outside world while you feel almost nothing. Time doesn't break, it simply flows in a direction shaped by gravity. Let's compare 1 year experience near each object. Earth, 1 year's, white dwarf, is almost equal to 0.9999 Earth years, neutron star is almost equal to 0.5 to 0.8 Earth years. Near a black hole, 1 year for you could equal hundreds or thousands of years on Earth. Gravity doesn't just bend space, it bends time itself. The deeper truth is simple, time is not universal, it's shaped by gravity, stretched and distorted like fabric. From mountains on Earth to the edge of a black hole, time flows at different speeds everywhere. Where you stand determines how fast you age, and in the strongest gravity, time almost stops. Even so, your own experience feels perfectly normal, reminding us that time is both personal and profoundly shaped by the universe, and it means that every moment you live is part of a much larger cosmic rhythm. That's it for today's video. If you enjoyed exploring with me, don't forget to subscribe to Science Lab, where we turn everyday things into scientific discoveries. See you next time.